Good afternoon, everybody. Today we are going to discuss Programmable Peripheral Interface IC, which is 8255. In first part of this chapter, IO interfacing, we have discussed what is going to be the input interface circuit, what is going to be outer interface circuit. Like whenever we are talking about IO interfacing means what? Whenever we want to connect any input output device to microprocessor, what should be the interfacing device in between? What should be interfacing device in between? That interfacing device will be like, you can have a separate input interface circuit which will be taking care of the mismatching between input device and microprocessor. You can have a separate output circuit which will take care of the mismatching between microprocessor and output device, right? Similarly, we have also discussed how those 20 address line can be decoded, and accordingly the IO addresses can be obtained. That also we have discussed. So we have discussed, because there are two different kind of IO mapping, IO map IO and memory map IO. Whenever we are talking about IO map IO, you are going to have only 8 address, you will be using only 8 address bits, right? So in that case, you will have to decode only 8 address bit. However, in case of memory map IO, we'll be utilizing 16 bit out of 20. Therefore, we need to decode a 16 IO address bits, right? So accordingly, we have in the last lecture, we have discussed how those 8 bit can be recorded, and accordingly how the IO addresses can be obtained. Similarly, we have also discussed circuit by which we have seen how 16 bit can be decoded and how the addresses of the IO devices can be obtained. So this section we have already discussed. What does this section talks about? This section which we have discussed, I'm talking about, talks about that you can have the discrete input circuit which will take care of the mismatching between input device and microprocessor, discrete output circuit which can take care of the microprocessor and output device. Rather, instead of having two different circuits which will be taking care of mismatching between input device and microprocessor and output device, you can have the integrated, programmable peripheral interface IC, which is in the form of 8255. This 8255 consisting of both. It consisting of input interface as well as output interface circuit. You don't need to connect separate circuitries as far as which will be taking care of mismatching between input device and microprocessor and output devices. This peripheral interface is known as peripheral interface 8255. 8255 is the name of, number of the IC. Now, why it is called programmable? Because we can program it. We can program it. Means, like in this IC 8255, we are going to have 3 different ports which can be programmed as per our requirement. I mean to say, like the same port can be considered as the input port through which you can feed data, or same port can be considered as the output port through which you can take data from the microprocessor, right? The same IC, which can be programmed, right? Which can be programmed as per our requirement, and therefore it is called as programmable peripheral interface IC, which is level 8255. Now, since this is very important IC, we like half portion of this chapter has been devoted for this particular IC. What are the features? It is a programmable device. As I mentioned earlier, this is programmable device. It has got 24 IO programmable pins, which consisting of port A, port B, and port C. Each port A has 8 pins, port B has another, port B has another 8 pins, and similarly port C also has 8 pins. So altogether, IO programmable pins would be 24. This particular IC is TTL compatible. So whatever transistor logic is going to be there, that is going to be like this IC is going to be compatible with TTL logic. It has got improved DC driving capability. Like I told you earlier, interface doesn't mean that only because whenever we are talking about mismatching means like current requirement of microprocessor, current requirement of input, like whatever the mismatching of current requirement of input device and microprocessor and output device, that is going to be taken care of by this interface circuit. It means that whenever it is needed, the current driving capacities can be enhanced. So this IC has got that capability as well. So this is pinout diagram of this IC. You can see, as I mentioned earlier, this particular IC has three important ports: port A, port B, port C. You can see right from 1 to 4, this is PA0, PA1, PA2, PA3, and 37, 38, 39, and 40. These are PA4, PA5, PA6, and PA7. It means 1 to 4 and 37 to 40, these pins belongs to port A. Then 5 belongs to RD bar, because whenever you want to read, because this is going to be interface between input device, output device, and microprocessor, right? So you need to, whenever you want to read something from microprocessor, you need to activate RD bar signal. If you want to write something into the processor, you need to activate RWR bar signal. Therefore, we have got RD bar signal, which is at pin number 5, and WR bar signal, which is at pin number 36. CS bar is pin number 6, which is being used to enable this IC. Keep enabled, right? We need one more pin for ground, GND, which is at pin number 7. And pin number 8 and 9, this is A1, A0, and A1. A1 being a MSB and A0 being a LSB. These two address pins are being utilized to select one of the ports. Like as I mentioned earlier, there are three ports: port A, port B, port C. So whenever it is 00, port A, 01, port B, 10, port C, and whenever it is 11, it will be control word register. I will be telling you what is the control word register in due course of time. Then number 10 to 17, these are port C. You can see PC0, PC1, PC2, PC3, PC4, PC5, PC6, and PC7, because each port has 8 pins, as I mentioned earlier, right? So pin number 10 to 17 are reserved for port C, and 18 to 20 and 21 to 25. These pins, like I mean, like 18 to 25, these pins are being used for port B. PB0, PB1, PB2, PB3, 4, 5, 6, and 7. 26 is VCC, because you need, whenever you want to have the because there should be two at least terminal. One should be for VCC, and other should be for a ground. So this is VCC terminal. And then 27 to 34, these pins will be reserved for connecting it to data bus of microprocessor, right? Because we know, as far as 8086 microprocessor is concerned, we have got 16-bit data bus, and 8085 has 8-bit data bus. But this 8255 can be connected to either 8085 or 8086, doesn't make any difference. But this IC has got only 8 lines, 27 to 34, and 35 is being used to reset. So whatever internal registers are there in 8255, all can be reset. So this is for number reset is number 35. Let me explain this again, like function of the pin. I have already explained, but this is just a quick overview again. Data bus D0 to D7. These are 8-bit bidirectional buses connected to 8086 data bus for transferring data. Okay, so this has to be D0 to D7, as I mentioned earlier, D0 to D7 connected to 8086 data bus. CS bar, this is active low signal. When it is low, the data is transferred from 8086. I mean, data is transferred means, because mainly this is being used to have interconnection, interfacing of IO devices. It means data either will be transferred from microprocessor to output device, or input device to microprocessor, right? So CS bar, this is being used to enable the chip. So you need to enable the chip. If you want to transfer the data, you need to enable the chip. So you need to be 0, because it is active low. RD bar, this is read. This is active low signal. When it is low, read operation will be initiated. Write, when this is active low, write operation will be initiated. So read and write operation can be initiated by putting active low signal at read and write. Similarly, addresses A0 to A1, as I told you earlier, A1 being MSB and A0 being LSB. 00 means you will be able to select port A, 01 port B, 10 port C, and 11 control word register. Now, what is control word register? This is something like whenever you want to select port A, and if you want to use port A as an input port, So accordingly, you need to write a control word in control word register, because this can be programmed. We call it as a programmable peripheral interface. This is how we can program. I'm going to tell you what should be the control word, what is this format. But you need to, if you want to write something into control word, then you need to know how to access that, right? A1 and A0 is going to provide you opportunity to have access to control word register. Then reset, this is used to reset the device. That means all internal devices to registers inside 8255 are going to be reset. P0 to P7, it is used, it is the 8-bit bidirectional IO pins used to send data peripheral or receive data from peripheral, right? This is essentially port A. And similarly port B, P0 to PP7, port B. PC0 to PC7 is similar to port C, but the port B and port A, but the difference is going to be these pins cannot be splitted. Port A and port B cannot be splitted down. All 8 pins can be used simultaneously. Whereas, as far as port C is concerned, that port C can be splitted into two groups. That has been splitted, rather, that has been divided into two groups. PC0 to PC3, that is lower group, and PC0 to PC7. So you can select only upper part or lower part. Whereas as far as port A and port B is concerned, you don't have this kind of option. There, the entire port need to be selected. These two groups working in separate using 4 data. As I mentioned earlier, port A and port B cannot be separated, cannot be divided, but port C can be divided, and accordingly only half of the port C can be utilized if needed. This is block diagram of 8255. You can see this again. This is very easy to understand. You can see, as far as the block diagram is concerned, we have got data bus buffer in between. So what is the purpose of data bus buffer? Purpose of data, you can see the input. This is coming from the data bus of 8086 microprocessor, and it goes to the internal data bus. It means this data bus buffer is going to take care of the mismatching between the 8255 and the 8086 or any processor. It could be 8086 or 8085, right? So that is why it is bidirectional, because data bus is bidirectional. So data, the same bus is being used to receive the data from microprocessor or to send the data to the microprocessor. Read write control logic, another block is read write control logic. It has got RD bar, WR bar. You can see RD bar and WR bar, these are active low. So if you want to read the data from microprocessor, you have to activate low signal, RD bar signal. And if you want to write something into microprocessor, then you have to activate active. You need to send active low signal at WR bar. And this A1 and A0, as I mentioned earlier, these pins are being used to select one of the ports. Either port A, port B, port C, or whatever, right? And reset, as I mentioned earlier, reset, this is the pin which is being used. This is the signal which is being used to reset all internal registers. And CS bar being used to enable the IC. Okay, this is all about read write control logic. Now then, next is, this is group A control and this is group B control. What does it consisting of? Group A consisting of the port A and upper part of port C. Group A consisting of the port A and upper part of port C. It means this is going to be control of the transfer of data as far as port A is concerned, upper part of port C is concerned. So this particular block is going to take care of transfer of data between microprocessor to the IO device and IO device to microprocessor, vice versa, of as far as these two ports are concerned. Similarly, you are going to have another group B consisting of port B and lower part of port C. Port B and lower part of port C. So this is going to take care of transfer of data between the microprocessor and the peripheral and peripheral to microprocessor. And group B will be controlling these two ports. And this, you can see, this is IO PA0 to PA7, and this goes to the IO devices. This also can be goes to IO devices. This is PC. This is port C, upper part of port C, lower part of port C, and this is port B. So any device input, that's why it's called I/O. It means you can connect either input device or output device. So whatever I have explained, this is again the review of the same thing. It is an what is data bus buffer? This we are talking about this data bus buffer. What is data bus buffer? It is an interface between bit bidirectional data bus of microprocessor and 8-bit internal data bus of 8255. So this is the 8-bit data bus of microprocessor. Out of 16 bit, only 8 bits are being used, right? And this is the interface between the 16 data bus and 8-bit internal data bus. It is used to interface between 8255 data bus and 16 bus, as I mentioned earlier. The internal data bus and outer pins D0 to D7 pins are connected internally. Right? So this is going to be connected to this pins through this data bus buffer. The direction of the data buffer is decided by read-write control. So direction, I mean whether it is incoming or outgoing, it depends on the RD bar signal or WR bar signal. If it is RD bar, it means you are reading data from microprocessor. So it will be incoming. If it is W bar, it means you are writing something into microprocessor. It means it is going to be outgoing. So direction is going to be decided by RD bar and WR bar. Next is read-write control logic. This is getting input signal from the control bus and address bus. Those signals are there, RD bar and WR bar, as I mentioned earlier. It consisting of address signals A0, A1, and CS bar. 8255 operation is enabled or disabled by CS bar. So, as I mentioned earlier, these are the control signals which are there to read-write logic control. We have already explained that. Next is group A and group B control. This part, group A control and group B control, right? This and this section. You can see here the group A and B get the control signal from CPU and send the command to the individual control block. CPU means the system bus. It could be 8085 or 8086. Group A send the control signal to port A and port C, upper part of port C. So group A will be responsible for controlling the operation of port A and upper part of port C. Group B is responsible for controlling the transfer of data of port B and port C. Whereas port A, now this is more about port A. Port A is, this is an 8-bit buffered IO latch. You see, buffered IO latch means IO latch because see, it has got both latching capacity as well as buffered capacity. If you remember, we always got an input buffer and output latch. So why input buffer? Because whenever you are talking about the sending data to the processor, you need to have the buffer circuit. And whenever you are, when microprocessor is transferring data to the output device, you need latch circuit, right? Latches, so that it will hold the data for time being, and you will be able to visualize the data. Otherwise, every data bus will be holding data for less than 1 microsecond, and which is not going to be enough for our human eye to visualize the data. Therefore, you need to latch the data. But so this port A as well as port B, they have both the capacities. It can be programmed by in mode 0, mode 1, and mode 2. In fact, 8255 has got 3 programming mode 0, mode 1, and mode 2. There are 3 different modes, and port A can be programmed in all 3 modes. As far as port B is concerned, this is also again 8-bit buffer IO latch. It can be programmed in mode 0 and mode 1. So port B can be programmed only in mode 0 and mode 1. Mode 2 we cannot program. As far as port C is concerned, this is again 8-bit unlatched buffer input and output latch, because this is unlatched buffer. This buffer is unlatched buffer input, but output is latched. It means that input is not latch, input is buffered, and output is latch. Okay, it is split into 2 parts, as I mentioned earlier. The port C is split into 2 parts. It can be programmed. The upper part of port C and lower part of port C. Most importantly, this can be programmed by bit set and reset operation. Means individual bit can be set and reset. I am going to tell you how. Whereas in case of port A and port B, it is not possible. Either entire 8 bits can be 0 or entire 8 bit can be 1. Okay. Whereas here, it can be any bit can be 1 or 0, but you cannot control individual bit. Whereas as far as port C is concerned, in bit set reset mode, there are 2 different modes of 8255. One is IO mode, other is bit set reset mode. That I'm going to tell you in detail later. But in bit set reset mode, only port C can be used. Port A and port B cannot be used in BSR mode. BSR means bit set and reset mode. Port A and port B cannot be used in BSR mode. Whereas port C can be used in BSR mode, wherein individual bits can be controlled. Individual bits can be controlled as per our requirement, and devices can be operated accordingly. Now, what are the operation modes? This is all about, like we talked about features of my 8255. We talked about the pinout diagram of 8255. We talked about block diagram. Now, operation modes, right? The first operation, as I mentioned earlier, 8255 can be work in two different modes. One is bit set reset mode. Other is IO mode. Now, what is bit set reset mode? The port C can be set or reset by sending out instruction to control register. So whenever you are sending some instruction, what that instruction is going to be, that I'm going to tell you. To control what register, you can control the individual bits of port C. This is, I mean, in bit set reset mode is specifically meant for port C. In case of IO port, this is like in IO port, then there are three different modes: mode 0, mode 1, and mode 2. In mode 0 is referred as simple IO mode. Mode 0 is referred as simple IO mode. In this mode, port A, B, and C are used individually. Simple IO mode, right? Simple IO mode. Individual, all pins, like port A is independent, port B is independent, port C is independent. It can be either input or output, right? What are the features? Outputs are latch and inputs are buffer. Inputs are not latch, inputs are buffer. Ports do not have handshake or interrupt capabilities because you don't have handshake signal in simple IO mode. It is there in mode 1, right? Mode 0 is without handshake, right? So it doesn't have any handshake or interrupt capability. And this is how the modes is going to be. No, sorry. This is like overall feature of mode 0. We are going to discuss in detail mode 0 as well later. And first of all, I'm giving you the overall idea. Mode 1 is like IO mode with handshake. So mode 0 is a simple IO mode, whereas mode 1 is IO mode with handshaking signal. Now, this is the schematic, the very simplified schematic of mode 1. In this mode, input output is transferred by handshaking signal. Now, what do you mean by handshaking signal? Because earlier also I told you what is handshake means. Handshaking signal is used to transfer data between the microprocessor and the IO device, right? But what happens, you can see here. Let us say this is computer and this is printer is one of the output device, right? So whenever the microprocessor sending or computer sending data to printer, it is going to send a strobe signal. So whenever strobe signal is received by printer, it means that the microprocessor or my computer has placed data on data bus. What it has to do, it has to quickly acknowledge first that yes, I have received the data, and then it will some time, because printer is going to be slow device as compared to microprocessor. It will take some time. So as long as printer is doing that operation, reading operation, it will show busy signal. Right? So since busy is active high signal, it is going to show logic 1. So as long as this is logic 1, it means that computer will have the impression that printer is downloading the data, printer is printing the data, right? So my computer is not going to send another byte of information. Once it becomes 0, it means that whatever data which was transferred in earlier cycle, that has been completely printed by the printer. Now computer will be ready to send another. It means what happens, these three signals are going to exchange: strobe, acknowledge, and busy. And this exchange of signal is nothing but handshaking that we have already discussed earlier. So this is example, the same example which I have explained. The computer send the data to the printer, a large speed compared to, so because computer has got larger speed as compared to printer. When computer send the data according to the printer's speed, at the time only printer can accept. So whenever computer is going to send the data in accordance with the printer speed, then only printer is going to accept. Otherwise, what will happen? It will take some time, and therefore what computer will do? Computer will place the data here once, and at the same time it will place the signal strobe. Whenever printer receives strobe signal, it means that it will understand that yes, some data is there. So by that time, computer will be holding back, right? And then once it receives strobe signal, it will acknowledge that yes, I have received your signal. Let me see. So quickly acknowledge active low, and then it will put logic 1 here, because it will take some time for printer to print that data. So as long as printer is printing the data, it will show logic 1 signal here. It means printer is busy and computer is not going to send another byte of data. Once the data is printed, then it will show logic 0 signal. Okay, and then it will get an information, get an idea by the computer that yes, now whatever the first byte of information, first batch of information which was sent to printer, has been printed. Now I can send another byte of information, another batch of information rather. This is how the handshake can be done. And mode 2 is going to be bidirectional IO transfer mode, right? This mode, because mode 0 is simple IO mode 1 is strobe IO. We can call it a strobe IO or IO mode with handshaking. Either you can call it as strobe IO or IO with handshaking. And mode 2 is going to be bidirectional IO. This mode allows bidirectional data transfer over a single 8-bit data by using handshaking. The feature is only possible with only group A. It means it is only possible with group A. And what does group A consisting of? Port A and upper part of port C. Port A is working as an 8-bit bidirectional, and PC3 to PC7 is used for handshaking purpose. It means, because whenever we are talking about bidirectional, we need some some bits for handshaking. So this PC3 to PC7, these 4 bits will be used for handshaking. Handshaking means exchange of signal, and actual port A is going to be used for transfer of data from microprocessor to microprocessor to IO device, or IO device to microprocessor. Okay, so this is how the port C, handshaking can be done. So what is the difference between mode 0, mode 1 and mode 2 then? Mode 0 is going to be simple IO mode. Mode 1 is going to be strobe IO mode, in which all three, like in mode 0, all 3 ports can be used in simple IO mode, all entire port. Mode B, mode 0, you can use the strobe IO mode, right? And mode 2 is going to be mode 1 is strobe IO mode, and mode 2 is going to be bidirectional IO mode, in which group A will be used, only group A. Group A means the port A, and remaining part will be the exchange of, like, PC3 to PC7 is going to be used for exchange of signals. Now, what is the format of control word registers? Let me tell you the format of control word register, and then once we understand this, then we will go for the detailed operation of port, all 3 modes: mode 0, mode 1, and mode 2. Now, in input mode, in fact, all 3 formats, all 3 registers, ports can be worked as a input mode or output mode. Because in input mode, like whenever you are putting logic 1, it considered as the input port, and whenever we are putting logic 0, it considered as the output port. This is the format. This is how we can program 8255. This is the format of command word. Command word means control word register. CWR, control word register. It has got 8 bits, right? You can see, and this D7, this 7 bit is 1, means this is IO mode. As I mentioned earlier, this 8255 can be configured in 2 modes: IO mode and bit set reset mode, BSR mode. When this bit 7th bit is 1, it means IO mode, and when 7th bit is 0, it means it is BSR mode. Okay, so let me tell you this. Okay, this is that way. Is a command byte A and the command byte B. This command byte B use only set and reset any bits of port C. This is only applicable for port C, not other pins, right? So you can see here D7 is 0, right? Whenever D7 is 0, it means you are essentially accessing port, the BSR mode, right? In this case, 4th, 5th, and 6th bit can be anything. Don't care, can be anything, right? And this first, second, and third, this will decide to select the bits of port C. You can see, because since there are 3, it means what are the possibilities? 8 possibilities, including 0, 0, 0. So first is going to be 0, 0, 0. When this is this first, second, and third is 0, 0, 0, it means PC0 will be selected. 0, 0, 1, PC1 will be selected. 0, 1, 0, PC2 will be selected. Like that, when it is 1, 1, 1, PC7 will be selected. So it means individual bits of port C can be selected. Now once it is selected, you can set or reset. When you put logic 1 here, it means set, and the logic 0 means reset. It means if it is 0, 0, 0, and 0 here, it means PC0, you will be essentially making reset. When it is 0, 0, and this is 1, it means PC0 is going to be set. So accordingly, all bits, say all 7 bits of port C can be either set or reset in case of BSR mode. That is why it is called a bit set reset mode. The another mode, as I mentioned earlier, when it is 1, it means IO mode. If it is IO mode, then how this is to be interpreted, right? You can see now 0th position will be responsible for setting configuring port C. Which port C? Lower part of port C. This is group B, right? So 0th bit will be lower part of port C. But if you put 1, it means lower part of port C would be input port. When it is 0, it would be output port. D1 bit would be responsible for configuring port B. If it is 1, means port B is going to be input, and 0 means port B is going to be output. The second bit will be responsible for selecting mode. As I mentioned earlier, there are 3 modes, right? When it is 0, mode 0, and 1, mode 1. It means with second bit, with this bit, we will be able to select only two modes, either mode 0 or mode 1. Mode 2 cannot be selected by using this. Whereas mode 2 can be selected by using this 5th and 6th. You can see here 5th and 6th, 0, 0, 0, 0 means mode 0, 0, 1 means mode 1, and 1 don't care. 1 don't care means mode 2. So you can have 0, 0, 0, 1, 1, 0 means any mode, right? So 0, 0 mode 0, 0, 1 mode 1, and 1 followed by don't care. It can be 1, 0 or 1, 1. Will be able to select mode 2. So accordingly, all 3 modes of operations of 8255 can be selected. Now, what about remaining 2 bits? Third bit will be responsible for configuring port A, right? This third bit will be responsible for configuring port A, right? So 1 means input and output is 0 means output. And similarly, the fourth bit would be responsible for, this is third is going to be responsible for not port A. This is port C, upper part of port C, PC4 to PC7. 1 will be responsible for input, and if you put 0, it means you are configuring port, upper part of port C as the output port. And as far as port A is concerned, fourth bit will be responsible for configuration of port A. 1 means input and 0 means output. It means this command byte A will be responsible for IO mode. Command byte B will be responsible for BSR mode. So again, let me repeat. D7 bit is 0, means it is set bit BSR mode. D7 bit is 1, means it is IO mode. So accordingly, this is the diagram by which we can program 8255, right? We are going to discuss various problems as well, how to program 8255. I'm going to take some examples at the end of this as well. Now, as far as all 3 modes are concerned, we are going to discuss these 3 modes in general in details later, because today what we have done, we started with the general feature. This is the general feature. Then we talked about the Pinout diagram of 8255. Then we talked about the functionality of all those pins, right? And then we discussed the block diagram and functionality of each and every blocks of 8255. And then we talked about the two main operations of 8255: bit set, reset mode, and IO mode, and what these three modes are all about. And then we also discussed today how to program 8255, like what are the how these 2 words can be configured, like byte A and byte B. We call this command byte A and command byte B. So there are 2 different mode, IO mode and BSR mode, and we have discussed how it is to be programmed. Now in the next lecture, I'm going to stop here today.